Hi folks, welcome back to Physics with Captain Rod. I'm making this one to help you out with number 14 in your Unit 2 homework. So let's see, find the acceleration of the car assuming the frictional coefficients shown, zero point 0.2 and 0.35. All right, so this is a fairly stereotypical Newton's second law type of problem. I would like to add that you shouldn't park on that steep an incline, but anyway, not relevant for the problem. And what you need to do is you need to draw force vectors acting on this car. And I don't really want to do that for you as it's your problem. But I will talk about the different forces. So we got the gravitational force, right? mg. Now, you might look at this and go, but I don't have a mass. Well, you have to kind of get over that. When you don't know a variable, or when you don't know something, typically what you do is you assign a variable to it and move on. So even though we're not given a mass, the gravitational force on that car is calculated by mass times gravitational acceleration. Put that force vector in your free body. Now, problems like this, it's really helpful to be concise. It wouldn't hurt to get a ruler out and draw nice straight force vectors. And keep in mind that the gravitational force is towards the center of the Earth. That's going to be a vertical force in this picture. Right? Now, there's also going to be normal force acting on the car. And remember that the normal force is going to be perpendicular to this surface. Right? That's what normal means. Then the frictional force acting on the car. Think about which way that's going to go. And make sure you honor its line of action. Right? The frictional force acts very specifically on the tires of that car. All right. Now, here's where things get a little tricky. This is a two-dimensional problem, and the acceleration, or at least the potential for the acceleration, I'll say right now, is in this direction. So I would work in a coordinate system that looks like this. All right, my standard rule of thumb, remember, is identify the acceleration direction, call that positive. So a coordinate system that looks like this has the plus x direction down and right. That should be a consistent way to work this problem. Now, when you're dealing with frictional forces, you typically need the normal force. So the car is not going to accelerate this way. So if you add forces in that direction, like that, I guess that's what I'm calling the plus y direction, they would have to add to 0. When you write that equation out, the frictional force should not have a component in that direction, but the mg will. After you write that equation, you should be able to calculate the normal. Well, you won't be able to calculate it, but what's going to happen is you'll get an equation over on the right, and it'll have an mg in it, and that's fine. So you can't get a number because we don't have the mass yet. But you'll get an expression that'll have the normal as a function of theta, and it'll also depend on this 30-degree angle here. But again, I don't want to rob you of all your fun. I want you to do that. Once you find the normal force, or at least an expression for the normal force, then come up with an expression for the maximum possible frictional force, which, remember, is the coefficient of static friction times the normal. Now, based on this problem, you're not going to be able to get a number here. You'll have an expression for this, but that's okay. And then compare it to the gravitational force component that is in this direction. And I'll go ahead and give you a little bit on this. The component of the mg in the x direction, if you have your free body correct and you look at it, should be equal to mg sine 30 degrees. This will kind of look similar. I don't want to give too much of it away, but it'll have a trig function in it, and you should be able to compare now this and see which one is bigger. If the maximum frictional force is larger than the mg sine 30, then the car is not going to accelerate. The answer is the acceleration is 0 and you're done. If the mg sine 30 is bigger than the maximum frictional force, then we know that the car is going to accelerate. But you also know to use the sliding frictional force now, which is the coefficient of kinetic friction times the normal. Then write yourself a force equation. Sum of all forces equals mass times acceleration in the x direction, like down and right. And you should be able to get the acceleration out of it. And when you finally get to this line, by the way, here's where the mystery will solve itself. The mass should divide out of that equation if you write it out correctly. So hopefully that'll get you through number 14. Again, I'm sorry, I don't want to spoil all your fun, so I didn't draw the free body for you or write the force equations, but hopefully this is good enough to get you well on your way. Have a great day.